So today we will introduce a new supervised learning algorithm, which is the decision tree. Well, we will not go into the details of the mechanism of the decision tree. We will just only talk about the Python code and the architecture of this algorithm. But let's talk a few words about it. So, decision tree is the iterative, the decomposizer, which is meaning it's splitting the data into two or more categories. It's a supervised learning algorithm, so you need to provide it the target as well as you need to provide the features. The algorithm, which is introduced by Rossi Quinlan, is basically a greedy uh, divide and conquer algorithm, which is meaning there is no packet tracking for the previous solution. So let's start up opening a new notebook. Uh, the decision tree it is utilizing the sklearn libraries, so with different functions here. So before we starting with the algorithm, we want to just take a look to the data, which is the in this data set, we are having a scenario where the doctor would be trying to classify the type of the tumor to be benign or malignant or cancerous or non-cancerous tumor, God forbidden. So we have import the pandas as a BD, and then we can call the data set. So here, data frame is calling bd dot read the SV file. So and you will find it in your Blackboard under the name of the breast cancer dot CSV. And we want to just take a look to it so we can have the data as a head. Let's say like the first 10 columns and run it. Now you can say like this is the patient ID, which is a string feature, so it has no meaning in as a feature. Then we have the diagnosis, which is the basically the target or the output that we want to diagnose. Then we have the other features like the tumor radius mean, the texture of the tumor, the perimeter, the area, the smoothness, and all the other features. Now, some of you will maybe kind of like afraid, okay, so we haven't seen any other category, so we are just only seeing the malignant or let's say the vicious tumor or the cancerous tumors. So we can simply say data frame, and we want to say the tail of the data set. So the listing values. If you didn't put any number here, it just will return the five latest ones. Okay, so we can see here it's have the benign. So we have a few categories, so we are fine with data set. Well, the decision tree algorithm also using sklearn, but it has a slight different nature from the regression model. So here we need to split the target from the features before we train the dataset. So let's import our important libraries that we're gonna utilize today. So from the sklearn, we wanna have the decision tree. So the sklearn for tree, import the decision tree classifier. Also from the same thing here, we will have what's so-called the basically the export library or function, export it to text, and this one is basically can give you the tree rules. So if you want to see like how from this feature started giving a decision. So how we done that? So this is basically help us through this function. And then finally, we will plot the tree. So the nice feature, there is a couple of nice features about decision tree. One of them is you can visually see how you have made the decision. So after that, we want to basically call the splitting the data set. So from sklearn, which we done it in previous ones, dot model underscore selection. So we want to import train and test and split. Um, of course, we want to assist this one here, but it's instead of using the mean square error and the coefficient of determination here, we will see the accuracy score. And we want in accuracy score, we want to just only see the sum lum of if it's categorized correct or not. So regardless if it's in the first group or the second group, or if the actual decision was correct. So was the prediction was correct, and if the decision was wrong, so and did the prediction model corrected wrong. So we don't look into this. So we are looking for the overall accuracy for the testing data set. And later on, we will go more specific. So sometimes we are looking for the negative, recalling the false recalls, or true positive or false positive, true negative or false negative, etc. All these things. So we have the sensitivity, specificity of one score. All these things will be discussed in different chapter, but for now, for simplicity, we just want to see the overall thing. So from, again, sklearn metrics. Sorry, import metrics. And we want to also have a help from the plot. So from or import math plots library, the Python plots. As a PLT. Now, the first thing is we want to split the target from the features. So we want to define Y and X. So Y will equals the data frame. Basically, here we have the diagnosis. So we can just copy this guy here and paste it. While X will be dropping this diagnosis. So df dot drop. Now open. We have the, sorry, this is should be banana bracket. The column name. So columns equal the diagnosis. And we can close the square bracket and the banana bracket. So we have done that. Now we can split the data into testing and training. So again, as we done it in the regression, so split to train and test. So this is going to be basically the same order. So X train, X test, Y train, and Y test will be equals to train, test, splits, X, Y, and then we have the test size. So we know the data set is not live. So the last column row was 568. So we're gonna stick with the formula 80 to 20. So 0.2, and we're gonna have a random state. One, two, three. After doing that, we will build the model. So building the model. So we're gonna train it. So you can call it a classifier or decision tree as you wish. So decision tree learning is equals to the decision tree classifier. Okay, let's call it decision tree classifier to make it more sense. Now we're gonna basically optimize it through the training data set. So the decision tree classifier dot, we're gonna fit it over the X training and Y training. Now, after we have built the model, we want to see if like our model is accurate or not. So here, model evaluation. So we wanna basically have the prediction for the testing data set. So Y predicts equals the decision tree classifier dot predicts. And here we're gonna use X test. Now we can have the score here. So the accuracy will equals to, you're gonna call the metrics. So metrics dot accuracy, this time underscore score, and this is gonna be between Y tests and Y predicts. And we want to print it out. So print the accuracy as accuracy. After doing that, we want to display the decision rules. So display the decision rules. So here the decision rules for our three rules as you wish. And this will be from this function here, which is the export text. So export text for the decision tree here. So decision tree classifier. And now we're gonna basically display the features that made our decision. So feature names equal the list of X column. And then we close it. After that, so we want to print it out. So print these decision rules. So decision rules. So we want to put it underneath that. So we need to have the backslash and this is going to be the three rules. Finally, so we want to display this decision tree. So it usually like it's kind of like upside down tree. So we're gonna plot it. So plot the decision tree for us, please. So this is the BLT figure. This is the frame of the figure. So this is the figure size, fig size. And this is like can help you out if you want to print it or whatever, or like just put it in a paper. Now we want to plot, use this function. So this is the first time, which is plot tree, plots the tree. Now we're gonna do the decision tree classifier. So this is the model. Now we want to display the feature name. So again, feature names. And this is again equals list of X columns. All again, or this time we need to display the classes or the targets. So class names equals square brackets the Benjamin. I hope I have spelled it correct. And the other class, which is the malignant. Malignant or malignant. And we want this to be filled and rounded. And we want to show the graph. So plt.show whatever we have made. Okay, I think it doesn't need dots. Okay, so in this scenario, we can see that the accuracy was like 93%. And well, if let's say we have diagnosed migraine and we will diagnose it as a cancerous tumor. So in it, maybe this is not sensitive as if the patient has cancer and we diagnose as not having not cancer. So like type 1 error versus 2 type 2 error could be sensitive in this case of scenario. Well, this is just saying like you assumed it's a benign and you didn't catch it or the otherwise around. So it's just providing the lump sum of everything. Uh, well, if we can run another model, let's see if we could have any enhancements over there. Well, it was a worse than this one. Okay, how about this one? It's slightly better. Okay, so you can try to different folds because we don't have much data sets. Now the decision rule is like tell you what if scenario and what else. So this is saying if we have the radius worse as this one, so we're gonna check this value for the concave points, then the area mean, etc. So this is will tell you what is this is the second class, class B. Okay. Now also you can see this is the sorry the non-cancerous tumor, and this is will head you to the cancerous one. So we have what if scenario, and this is very good, especially like if you have a reading and you can track it down. And this is starting from the most significant ones to the least significant ones. Now we have also the decision tree. So we can scroll or zoom in. Well, well, to be honest, it's like this tree is branched a lot. but you can have the visualization. So like what's happening with this variable, so how it's can expand. In theory, we don't, this is like an overfitting problem model. So it's unlikely to someone will like it. Okay, so now let's try to not make this tree as deep as it is presented. So let's create a second classifier. So we have the decision tree class 2, which is again the same thing here. So decision tree classifier. Now we want to train it in the same thing here. So we have, yeah, sorry, we're gonna want to fit it. But this time, let's take another values here now. So let's make it simpler. Okay, so the maximum depth for this tree, we want it to be only 3 branches. Okay, so we don't want to branch it. Now the minimum split also can help us. So let's make this consistent. So this is could be helping. Okay, so usually 2 is the best number. Okay, now the minimum sample leaves. So from here, like these are the leaves. So how much we want to branch from this one? So if there is a 1 can give us like the outcome, we would be uh, happy. Also here we can add the maximum number of features to make the decision. So maximum features, since we play with these ones, so let's keep it none. Okay, since we done that. And now you can add them the random state. So random state. And we're gonna use the same number we have used the last one and see if both of them will be the same. So it's 1, 4, 3. Let's see if there is any differences between them here. And then we're gonna train the model. So the decision tree classifier 2 will be fitted over the X train and Y train. And we will basically have the prediction. So Y predicts 2 equals the decision tree classifier 2 dot predict for X test. And we want to have also the accuracy again. So let's just copy whatever we have done from here. Okay. And just make a few adjustments. Okay, so we have the accuracy, what we call it, Y2 prediction. So this is will be Y2 prediction. Now this is decision tree 2. Here, decision tree 2. So let's see. We have done everything as it's supposed to be. And we're gonna run it. Okay, so we lost some of the accuracy. Okay. So we lost some of the accuracy, but the table now is like it's more friendly. So we have the rules to be more visually or nicer. Maybe if we can shovel this state, So let's say 1, 2, 3. Hopefully we can get something better. Okay. So not that much thing here. And you can see radius worst was the dominant in both cases. Um, uh, we can also try to do some enhancement here. So we can also put the criterion. So we're gonna basically have it on Guinea criterion. We have only two options, i.e. Guinea and entropy. So let's say with the entropy, because that's what we're gonna be introducing in next lecture. And also the splitters. We'll pick the best one. Of course, we want the best one. And we're gonna run it again. So the accuracy enhanced actually with entropy. So the default setting, I guess, is Gini. And but well also we could have different parameters here. Okay, so the state was 1, 2, 3. So let's say with 1, 4, 3 here. Okay, so it's also doing good. I think it's almost as the overcomplicated this one. Okay, so we could have better accuracy, I think, if we shovel it again. So like even overfitting not always will give you the best solution. So this is like overcomplicated the problem, and this is fine. So we are think in a good shape. Okay, so let's see the other algorithm that we're gonna learn later.